Welcome to the WattSherpa podcast, your guide to energy efficiency and savings.
I'm thrilled to speak today with Dr. Ming, a renowned climate scientist whose work bridges the natural and social sciences, fostering interdisciplinary collaboration to tackle climate change and environmental justice issues. He is a professor in the Department of Earth and Environmental Sciences at Boston College and also serves as the Institute Professor of Climate Science and Society at the Schiller Institute for Integrated Science and Society. Prior to joining BC, Dr. Ming held prestigious roles at the United States National Oceanic and Atmospheric Administration, where he served as a senior scientist and divisional leader at the Geophysical Fluid Dynamics Laboratory in Princeton, New Jersey. During his time there, he was also a faculty member in the program in Atmospheric and Oceanic Sciences at Princeton University, where he also earned his PhD. Dr. Ming's distinguished career is marked by numerous accolades, including the U.S. Presidential Early Career Award for Scientists and Engineers, which recognizes his contributions to advancing our understanding of climate science. So, Dr. Ming, thank you so much for joining me today.
Thank you so much, Carter, for your interest.
So, I founded WattSherpa in part to help young students like myself turn their passion for the environment into meaningful careers. And I always like to begin my interviews by asking how you discovered your passion for the environment and what academic path led you to your current role as a climate scientist.
Yeah, thanks for that question. As I understand, Carter, you're about to embark on your college journey. So
Yes.
Congratulations, first of all. And if I think about my college education, many years ago, obviously, I was a major in chemical engineering. So if you think about it, for a chemical engineer after graduation, your most obvious career path is to work in chemical industry. And then I realized chemical industry actually can give rise to a lot of pollution, so air pollution, water pollution. So I figured I should use what I learned towards more improving environment. So I took up a double major in environmental engineering. So as things turn out, you can use the same set of physics and chemistry to tackle different problems, whether it's in the manufacturing of plastics or you use the same principle towards improving air quality. It's the same physics and chemistry. So after that sort of soul searching in college, I decided to switch to environmental engineering for graduate school altogether. So as you mentioned, I did my PhD work at Princeton. So there I was in civil and environmental engineering. And after that, I got exposed to climate science, sort of fell in love with it. So I started to work on computer models to simulate the evolution of Earth's climate and to use the same computing tool to predict future climate change. So that's sort of the evolution of my academic career in a nutshell.
It's always interesting to hear everyone that I have the opportunity to talk to's background, because it seems like for such a large issue, people come from so many different backgrounds, education wise and otherwise. So it's always really interesting to hear where people's love for the climate really developed from. Your answer really went well into my next question, which was going to be, as a climate scientist, I know, like you mentioned, your work focuses on modeling the Earth's climate system. For those less familiar, could you explain what climate modeling really involves and how these models work and what their strengths and limitations are?
Right. If you think about our climate system, it is pretty much a mathematical/physical problem. So it involves solving a set of equations on a gigantic computer. So here the challenge is that we know those equations pretty well, but in order to model the entire Earth's climate system, you have to divide the atmosphere, the ocean into small boxes or grids. And then you solve the equations on those sort of grids. So pretty much the limitation is in the computing power. But we try to run computer model at high enough resolution to resolve certain phenomena like hurricanes, like mid-latitude storms or winter storms or say like nor'easter, if you're living in the northeast, so that you can better understand the impacts on local communities. So those computer models were invented maybe in 1970s or say. And actually, shout out to my former laboratory, GFDL, Geophysical Fluid Dynamics Laboratory. Computer models were invented there many, many
Oh,
years
wow.
ago. Yeah, to be honest with you, although I'm not there anymore, but I'm really progress accomplishment. And so computer models, as powerful as they are, they still have a lot of limitations. For one, as I alluded to, you're hindered by the kind of computing power you have. So your resolution is still relatively coarse.
Mhm.
So right now, the state-of-the-art climate models are running at, say, 50 to 100 kilometer resolution. So, but if you are thinking about you're covering the entire Earth, so it's not that bad. But they're not, the resolution is not high enough for you to cover, say, very fine features. So cannot study, for example, climate change at the sort of community level, neighborhood
Mhm.
or city block level, because you don't have the resolution to resolve all the flow. So we're trying hard to push that boundary, partly by taking advantage of the latest machine learning technique. So
Mhm.
there is ongoing work along that line. But all in all, those computer models and their simulations are the scientific basis for doing United Nations climate assessment for policy making. So they're critically important.
Yeah. I mean, it really is crazy to me how relatively new some of this technology is, but how large of an impact it's actually having. I know you just alluded to the rise of AI in your field and really in any field as of right now. So, looking to the future, where do you see AI or things like quantum computing enhancing your field and changing climate modeling?
Right. So you touched upon two aspects, AI and quantum computing. They're highly connected, but as we speak, they're still somewhat different.
Hmm.
So talking about AI, there are two basic applications. One is just like what Google has been doing, right? They to use AI models to emulate the behavior of weather models so that you can improve on the accuracy of weather forecasting. People are really pushing boundaries there, and so that's weather. But the same technique can also be, at least in principle, applied to climate modeling. So you use AI models to emulate the behavior of climate models. Once you learn the basic behavior of climate models, you can run AI models much, much more efficiently. So that's one application. The other one is just you still run what we call physics-based climate models. But as I mentioned, you have to deal with certain model resolution. So there's still a lot of stuff going on within one single grid box, right? So that's where you have to what we call parameterize a whole host of processes. So what you can do is that you can use AI models to emulate the behaviors of those subgrid processes, and then you put AI model into your physics-based host model to do a better job at simulating climate. So that's sort of the AI side. And on the quantum computing side, is instead, if quantum computing can become reality, then your computing power will be at a different level. So I will say then there you can easily probably run global climate model at kilometer scale. So that would allow you to resolve what's going on in a city block. So that will be tremendously powerful. Right now, with the existing more conventional supercomputer, we can push the boundary by running models at kilometer scale, but we can only run for a few months. Maybe if you really push it, maybe run about a year or so. But to do long-term climate simulation, you need to run model for centuries. That's only going to be feasible when you have quantum computing.
It's great to hear that you seem so positive on technology like this, as we're still in the developmental stage of it. So to think about kind of the growth that's going to be created by this technology in the future is super exciting. So I know we've talked a lot about computing and mathematics, but it seems that the frontier of climate science is also increasingly about integrating socioeconomic factors alongside things like math and physics. I know you teach a course at Boston College, Climate Change and Society, that explores the political, economic, and social dimensions of climate change. Could you share your perspective on how human activities are contributing to extreme weather events and how these dynamics influence the work that you do?
Right. I think it's a scientific consensus that anthropogenic greenhouse gas emissions are contributing to the observed warming of our climate system. So since the so-called pre-industrial time, the Earth has warmed by about 1.5 degree or so based on instrument record. So there is no dispute in the fact that fossil fuel burning was the main reason for that temperature increase. On the other hand, the issue you alluded to, the impacts on extreme weather events, that's still a very active research subject. There are certain physical reasons to expect changing temperature may have certain implications for weather events. But at the same time, climate and weather are very different things. You can perceive climate as average weather. If you study physics, you will see once you start to average things, the noise will be reduced, right? It's much easier to figure out what's going on. Weather, in a way, you can think of as noise. So, for example, right now during the winter time, the temperature from day to day can fluctuate easily by 10 degrees. Then you think about what I just mentioned, global temperature change, 1.5 degree. So that 1.5 is certainly within the fluctuation. So it's hard without averaging over the entire globe to figure out the climate change signal. Extreme weather events are relatively rare, right? If you think of how many storms you can have 1 year, how many hurricanes you can have over 1 year. And I think right now there are certain studies are pointing towards connections between climate change and extreme weather events, both in terms of frequency and intensity. But I think we need to do more research to really pin down the connection and probably more importantly, to better understand the physical mechanism responsible for possible connections between those two. But right now, I feel you cannot say too many things definitively about the potential connection between climate change and extreme weather events.
And I'm hoping that a rise in technology, like we were mentioning, specifically around AI, will really help solve a lot of these debates that are going on right now.
Certainly.
So shifting gears, I saw that you helped lead a delegation of students and faculty representatives to the COP28 Summit in Dubai, which is the UN's annual climate convention. And I saw that this group included experts from fields like business, law, science, social work. Could you share some stories from the summit and how you saw interdisciplinary collaboration driving some of that global impact?
Right. It was really an eye-opening experience. We learned so much from attending the conference. We also learned so much from talking to each other just within the delegation. As you mentioned, it's a very dynamic group of people from very different disciplines. On a particular day, we were at this pavilion about climate finance. Right? If you think about the transition to net zero, how much new investment that will require for having all the renewable energy we need for getting to net zero, financing is going to be a big part of the puzzle. And our delegation, we have a dear colleague in the Carrot School of Management, right? CSUM, for those who do not know all the detail about Boston College. So here we do have a School of Management, highly regarded in the field. So as a natural science professor, I didn't get the chance to talk to my colleagues in school of management all the time. But on that trip, I was talking to this professor in marketing a lot, and we were just checking things out in the climate finance pavilion. We just talking about the critical need to have a climate finance course at BC so that our finance major or econ major can have the necessary exposure to climate science and to other financial aspects all at the same time. So we sort of cooked up a few ideas, and now we're thinking about jointly holding seminars on climate finance at BC between Schiller Institute and the School of Management, and having an expert coming over to talk about climate finance, this important issue. Then maybe we can come up with a syllabus based on the lectures by stealing ideas from us. Because I was joking. Right, but that's still part of the learning process. I'm trying to think of a word to convey the gravity or how important that is for my own understanding. Also, I don't know, how inspiring experience was that I was at this planetary session. There were the invited guests were actually female farmers, women farmers from India, and they were talking about their adoption of solar panel empowering irrigation because they have to otherwise carry water for irrigation using a bucket. And now they can, because electricity is very expensive, not widely available in the countryside. So now they have access to solar panel, so they can power pumps for irrigation. That sort of saves them a lot of time and allow them to pursue other things in their life. And I was listening to their also like testament and to see how liberating that kind of technology adoption could be for rural populations in low and middle income country. I was in the audience, I was thinking about it, right? So in this case, I'm not dealing with this abstract concept like math or physics. And here, I feel like what I've been doing could be actionable at the ground level to really improve people's life. And I just feel like this gave me extra motivation to do better work once I return from the COP conference. I feel you can learn so many things from different by attending such a conference.
It just sounds amazing that it really is true that whether you're talking to a professor of management or farmers, you can really get a new, unique perspective on the climate issue and how it's affecting people's lives and the different ways that it really intersects into every industry and way of life. That's really an inspiring story.
Thanks. So if you think about it, if I may, climate finance, you're talking about also investment banking kind of thing. Now you're talking about improving the quality of life of rural farmers in developing country. In a way, there are also like two ends of the spectrum, but they're intricately connected at so many levels. At the end of the day, we're talking about real people, humanity being involved. It's just tremendous.
Adding on to that, a significant challenge in addressing climate change is the issues of climate justice. Industrialized nations have contributed the most to global emissions, while developing countries disproportionately suffer the consequences, since climate patterns obviously don't respect borders. I saw that your research includes studying the impact of man-made aerosols on the South Asian monsoon, which is a system that billions of people depend on. Could you tell us more about your work in this area and its implications?
You're referring to a paper I published actually with my very first postdoc about maybe 10, 12 years ago. It's about air pollution, especially in East Asia and South Asia. You have a lot of air pollution. They are little tiny particles suspended in the air from human activities. Those particles, they can scatter sunlight back to the outer space. So in a way, they can cool down the climate, just very different from greenhouse gases. Actually, people know as a fact that aerosol particles can cool down the climate from volcanic eruptions. After major volcanic eruption, the Earth's temperature will drop quite a bit, and through the same process. But what we did in that paper was to show that aerosol cooling can actually alter the Earth's water cycle as well. It's not just temperature, because at the end of the day, you need sunlight to drive evaporation. Evaporation is the ultimate source of water and the rain. So by shielding the surface from sunlight, you reduce the evaporation. You can also reduce the temperature contrast between the two hemispheres. During summertime, when Asian monsoon takes place, the northern hemisphere is a lot warmer than the southern hemisphere. So you have a circulation going on between the two hemispheres. By cooling down the northern hemisphere through air pollution, you reduce that certain contrast. As a way, you reduce the stress of the Asian monsoon. So that can cause drought condition, affect people's livelihood. So that's about 12 years ago. And at BC, actually, I moved here 2 years ago. And so the latest sort of twist to that story was that actually I've been working with my colleagues in the School of Social Work at BC. Once again, in case you don't know enough about BC, in addition to the School of Management, we also have a world-class School of Social Work. So there, people work at the community level to better understand the social behavior, to come up with what we call intervention strategy to improve people's quality of life. So I worked with colleagues in the School of Social Work to apply that kind of climate science knowledge to improving people's life quality, especially the rural population in India. So we wrote a proposal to examine the impacts of climate change on the mental health of rural population in low and middle income countries, using India as a study case or proof of concept. So the idea is that through the weakening, as I mentioned, of the monsoon system, the drying, you may cause more permanent crop failure. So that may affect farmers' livelihood, and then that will affect their mental health. So that's a connection. We started to look at the physical science. Now we're trying to apply that physical understanding towards community level intervention effort.
And like you were mentioning before, I think it's always good to remind people that it's not just math and science, but this is really affecting human lives as well, down to the community and individual level. So it's great to hear that you're doing that in collaboration. Sounds really interesting.
Collaboration is the keyword, for sure. You cannot do it all.
So from your perspective as an educator, researcher, participant in global climate forums, I'd like to know how you view the balance between climate adaptation and mitigation, because to some extent, we are unfortunately locked into certain near-term climate outcomes. What do you think that we should expect, and how can we minimize the impact of climate change while also continuing to push for more long-term solutions?
I feel both mitigation and adaptation are critical. We don't have the luxury to choose one over the other. And ideally, you want to just address the issue at the root cause, right? By mitigating greenhouse gas emission. But on the other hand, we understand our entire economic system, our society as a whole, have been built around fossil fuel. So it's kind of hard to break out of that habit. You also alluded to there is certain amount of climate change built into the system already because of the inertia of the system. So that means we have to pay a lot of attention to adaptation, especially once again on the community level. For the last 2 years, Boston downtown actually is just barely above sea level, along in reclaimed land. Then you think about the rising sea level, and during the Easter, all the storm surge, the coastal inundation, everything, that's going to, you have a lot of valuable properties along the coastal line. So you have to think about ways to address the climate resilience issue. On the mitigation side, this country has been investing a lot on renewable energy. Once again, back to my collaboration at BC, I've been, in the last 2 years, I've been working with the econ professor on renewable energy, in particular wind energy, we're trying to use a climate model to study availability and reliability of wind energy in a different climate system. Because there is an argument winds may be weaker in a warmer climate based on physics. Now we're trying to figure out what's the implication for your power grid, what's the implication for battery storage if winds are more sporadic. So I feel we need to tackle both ends, and there are a lot of opportunities out there associated with green transition.
I love your phrasing of the idea that we don't have the luxury to pick one or the other. And I mean, it's 100% true. We really have to put our full energy into both, unfortunately. You've gotten to talk a lot about the collaboration that you're doing at BC with the Schiller Institute. And I know you were among the first professors hired to help lead it. Do you want to just share a little bit about the mission of the Institute and just kind of like you were talking about how you collaborate across disciplines to advance those goals?
In a way, the Schiller Institute is an ongoing experiment here at BC. The idea, I think the effort started, at least the conceptualization of the Institute started maybe more than 10 years ago. It's a lot of people's collective effort to make this finally a reality on the ground. So in that way, I'm the beneficiary of my colleagues' work. So officially, the Schiller Institute started about 5 years ago, and it's built on this naming gift from Phil Schiller, a BC alum and Apple senior executive. So the idea is to build on the existing strengths at BC, both in natural sciences, social sciences, and humanity, to bring folks from disciplines together to tackle some what we call grand challenge problems, especially in the field of environment, energy, and health. So it's not just about doing cutting edge research in those fields. It's also about how to use research to advance pedagogy at BC to better equip our students with the state of our science and the technology, and also this sort of whole person education BC has been doing so well for so long. So we thought climate change, as you mentioned, could touch upon so many different threads of our social fabric. It could be a good way to bring people together, just get people interested to work on some common problems. So I guess that's one reason I got hired as a climate scientist in the first place. So in the last 2.5 years, I've been reaching out to colleagues in different departments, different schools. So I mentioned ongoing collaboration with the School of Social Work, with our econ department. And going back to your original point about AI, the department chair of computer science, I know I just hired our joint postdoc who started 2 months ago or 2 weeks ago, or more precisely. And so I feel the idea of having an interdisciplinary institute at BC, leveraging the existing strengths while venturing out to new fields of study is really paying off. And it's a learning curve for sure, but we're publishing, we're getting external funding, we're building research alliance in a way with other universities in the Boston area. We're also working on national and international projects, in particularly in the global south. So it's a lot of accomplishment in relatively short time. So we're very part of that record. But this would not have been possible without the strong support from the university, from our alum, our students, and so for that, I'm forever grateful.
Yeah, I mean, the Institute just sounds like it would be such an amazing opportunity to participate in something like that. And I think to a degree really reflects some of the goals I had in launching this website and conducting these interviews with experts across so many fields to really get those unique perspectives where those definitely unique solutions come in for problems. So it's great to hear that work is being done. So for my last question, From my research and just from this interview alone, it's clear that although we face many challenges, you do remain optimistic about humanity's ability to address climate change and reverse some of its impacts. So for a younger audience, I just would like to hear what advice you would give on how they can contribute to realizing that optimism and making a meaningful impact in the fight against climate change.
Yeah, young folks can contribute in so many different ways. But if there's one thing, I would just say stay engaged. Stay engaged is so important. Just I feel those days it's very easy to become cynical. That was cool. It's the old people ruin everything for us, and it's very hard to fix. And I just play along the whatever will transpire. I feel by staying engaged, you can see through the fog. You can, you know, some people saying what's going on is a crisis. I think that's the right framing, but with every single crisis, there is always opportunity. If you think about opportunity, you can learn so much about our natural environment, and then you can think about how to improve things from different angle, whether you're going to be an econ major or finance major working in climate consulting or climate finance, as we talked about, or you can be an environmental science major, studying the physical climate system, or you can be a political scientist, equipped with the latest climate knowledge to fight for the environment from the policy point of view through government service or NGO. But all those possibilities are conditioned upon being engaged. You cannot tune it out. You just have to put on a brave face and take the right courses, talking to the right people, and take the right internships, and just be at the free front of the struggle. And as grand as this challenge is with young people's creativity, their energy, I feel that I have every single reason to stay optimistic.
I think, like you're saying, it's clear there's going to be ample opportunities in any field to address something related to climate. It's just we need people willing to fill those shoes and really step in it and try to make that difference.
Right. At the end of the day, everyone has a vested interest in the
Yep.
struggle. So
Mhm.
you cannot shy away from your duty.
Yeah. Well, Dr. Ming, thank you so much for taking the time to speak with me. I've really learned so much from this conversation, and I'm excited to share it with the WattSherpa audience. And thank you for dedicating your career to helping train future climate leaders.
Thank you so much, Carter, for your interest.
Yeah.
Again, good luck to your college.
Thank you so much. So for anyone interested in learning more about Dr. Ming's work, I'll provide links to his BC profile, the Schiller Institute, and his Google Scholar page in the description. And you can follow him on X or Twitter at yiming245. So thanks again, Dr. Ming.
Okay. Bye-bye. Take care.
If you enjoyed our podcast, please like and subscribe and visit us at WattSherpa.com.